Welcome back to the Vex classroom. My name is Elena, and today we're going to be talking about arm design. So we're going to go over what is a robotic arm, 3 different types of robotic arms, and talk about what makes an effective robotic arm, and kind of talk about what you can do to make your robotic arm best suited for the challenge that you have. So a robot arm is a mechanism or machine that functions similarly to a human arm that is used to lift, move, pick up, somehow transport objects. And robotic arms really change depending on what they are being used for, what their task is. So robotic arms are used all throughout industry as well. They're used in manufacturing, surgery. So we're going to take a look at a couple examples. So as you can see here, you've got a robot arm being used in manufacturing, used in to seal jars in this case. So that might be something that could be difficult for a human or repetitive. So it might not be something that you would want to do yourself. You could get a robot arm to do that. There's also applications depending on if you're working with dangerous materials or sensitive materials. So here you can see this person is in their full safety gear. So that means that there may be something here that is dangerous or hazardous, some other way that it may need to stay sterile. So robotic arms can also be used in these kinds of contexts as well. Again, for, in this case, transporting objects. Beyond that, there's also surgical applications for robotic arms. So even today, there are robots performing surgery. They are led by surgeons, but because they have the ability to be so precise as a robotic arm, it's a lot more reliable than something like a human arm or a human hand that may have more of a tendency to shake or just have that margin of error that humans have when they complete a task. So you can have a lot more precision with robotic arms as well. So I want to go through and talk about 3 types of robotic arms. We're going to cover the swing arm, a 4-bar, and a double reverse 4-bar. So the first one that we're going to talk about is a swing arm. So a swing arm is used in the Vex IQ first generation Clawbot build. This is one of the simplest builds to make. It's just very easy to create this build, so that might be something that comes into consideration as you're building. With this arm, it lifts up here, and you just have this 1 bar. Now you'll notice that with a swing arm, it actually can go over the top and around. So let's go ahead and look at an animation and talk about a swing arm a little bit more. So with a swing arm, you can see here, this is an example built onto the BaseBot from the 2nd generation IQ build. And here you've got the tower, which is this main piece connected to the robot. You've got a motor here connected to a gear, and it is driving this long bar, this swing, and then it's connected to this manipulator here. This could be something that you use as a fork, as a scoop. There could be a claw at the end of your arm. That manipulator is up to you and what you want to design. So we have just a basic level here so you can see how it moves. So if we look at this animation, we can watch our swing arm go all the way around the robot. So this has a lot fewer pieces than other builds, which can make it simpler. It could be good for lifting some objects to a certain degree, but you also have to be really careful because if you don't control the height of where your arm is going, your object, whether that be a cube or another game piece, could get lifted up and actually knocked off the back of the robot. Maybe that's your intention, but you want to think about that as you use a swing arm. So here I have an example of a swing arm. This is a very basic example. You can do something a lot more complex, but you can see here we have our pieces. We have the tower that would extend up from the robot that connects our motor here to a smaller pinion gear that connects to a larger gear, and it has this shaft running through. So when the motor runs, it would actually lift our arm up and down. So here you can kind of see the little beginnings of what might be a scoop or a fork here on the ends. You can change this manipulator, but as it goes around, there's no limit to where the arm is swinging until this arm actually hits the gears on the inside. So the limitation, it goes almost all the way around on this build. Again, that can change on what you build, how many motors you have, if you want it to be a passive or an active manipulator. The weight that you add to the end of your arm can also change how much power your arm has while lifting. So that's another consideration to make. You want to make sure that you have enough power with the motors to lift and lower your arm as you go through as well. So this is a swing arm. Again, one of the most simple builds. This might be one of the easy ones to make if you have a short time constraint or you don't have as many materials. I'm going to put that with the first generation Clawbot. And now the next thing we are going to talk about is a 4-bar. So a 4-bar design is used in the IQ second generation Clawbot build. And we're going to talk through what the 4 parts of a 4-bar is. So right here, I have the 4-bar arm that was connected to the top of the second generation Clawbot build. I just removed it from the build and have this separately. And I also removed the claw from the front. So right here we have 4 kind of big pieces to talk about. You have the tower, which is piece 1. You have 2 parallel bars coming off of the tower. And then you have your tool plate or whatever is connected here at the end. So you can see that rectangle that it makes. Those are your 4 bars. 1, 2, 3, and 4. That's what creates the 4-bar movement. This is a little bit more complicated than the swing arm, but it also can give you some more strength because you have this additional bar here to help. In the Clawbot build, you also have rubber bands that can change the strength, and you have a second set of bars on the other side. So you actually have 4 bars in the middle of this arm. So let's go ahead and take a look at an animation of this going. So here you can see the IQ Clawbot, the second generation, and right next to it, you can see this line here. So in this animation, it's going to show you that a 4-bar design can keep objects completely level. You can see that if you watch the claw attachment here and the end of the tool plate. It can keep objects level, but there is a slight arc as you come out and go through. You can see that as it gets closer. So let's watch. So you can see it gets closer, and then the arm reaches a limitation as it's on its height. So you can see here, this is the limitation of the arm being raised. If we look back at our 4-bar here, you can see you've got the smaller gear connected to the larger gear, and the smaller gear is what the motor is driving. As it goes up, you reach a point of limitation. This bottom bar and this top bar actually start to, it looks like they're about to collide. Really, the gears, because the way they're turning, you can't extend beyond there because these two start to collide together. So there's a limit to how high a 4-bar arm might reach as it goes up. But this could be great for lifting something that needs to remain level. Whether that be something unstable, something else, you can keep that entirely level and just have a small arc coming out, as compared to the swing arm that has a large arc that just keeps going. So you can almost imagine that arc circle that comes around from here. So you've got a large arc with the swing. You have a small arc with the 4-bar, but it remains level as it goes through. The last robot arm that we are going to talk about is the double reverse 4-bar. So with the double reverse 4-bar, I want to start off by saying that this is one of the most complicated arms to build. You want to make sure that you have the time to dedicate to this build as you go through, and just be aware that it might be a little bit more frustrating than some of the other builds. But I know that you can build it. You just want to make sure you take the time to go through and look at all of these pieces that are needed. So let's go ahead and take a look at the double reverse 4-bar. So with the double reverse 4-bar, you can see here you have your tower at the bottom, the 4-bar piece coming out at the bottom here. There's 1, 2, 3, 4. You also have a secondary tower that extends up and actually connects the bottom 4-bar to the top 4-bar. So you have, again, that tower, the 2 parallel bars, and then this end bar that would be connected to your tool plate, in this case, another claw. So you have 2 4-bars that are linked together with this design. Now in here you can see there's a different series of gears that go through to move them one with the other. These are 1-to-1 gears here in the center. So as one gear moves clockwise, the other gear will move counterclockwise, which causes some of the movement of the double reverse 4-bar. So if we look at an animation of this, you can see here as it comes up, it can actually go all the way back down because of the way that the arms are slotted within one another. So right here, if you watch the claw, this build remains level. The tool plate, that tool piece, the manipulator, remains level throughout, and it also is able to move without an arc at the end. So if you're trying to stack things really high, if you want to go to higher levels, if there's another reason why you can't have an arc to your arm or it might be a detriment, the double reverse 4-bar is really the best way to go. So let's go ahead and watch this again. You can see it coming all the way up and stretching back down. And you can change the height of that double reverse 4-bar and how high it needs to go by changing the height of these towers as well. So you have the center tower, the bottom tower here second, and then this tower that's connected to the tool plate piece at the top of the 4-bars. So because this is a more complicated build, I do not have it in front of me. However, all of these animations are available for you in this lesson. So again, to look back at the double reverse 4-bar, this is a more complicated build, and you can see too they actually use 2 motors here because it takes more power to move some of these arms. So you also want to think about the materials that you have as you go through. So to recap, we're going to kind of go back over what is a robotic arm, the types, and then go over what makes an effective robotic arm. So far we have talked about how a robotic arm is a mechanism or machine that functions similarly to a human arm to lift and lower objects, to stack them, to move them, any of those applications. And there's a lot of applications in the industry as well. The types of robotic arms we have talked about is a swing, a 4-bar, and the double reverse 4-bar. So let's talk about what you can do to make an effective robotic arm. An effective robotic arm depends on what you are building and the task that you have. If you are looking to stack objects, you want to think about how high you need to stack those objects. Is the height of a 4-bar enough, or do you need that additional height from a double reverse 4-bar? Does it matter if you have an arc on the end? Do you have something where you can build a swing arm and actually still be able to accomplish those tasks as well? So you also want to think about the shape of the object you're picking up. If you're looking for a ball of some sort or other game object that's spherical, do you need it to remain level, or does it matter? Can you make a simpler build like a swing arm, use a claw to hold on to the ball, and then just use that quicker? Are you lifting cubes? Are you lifting something else that needs to remain level, like multiple cubes in a stack? All of those things come into play. You also need to think about, as you're designing your robot arm, how many pieces you have in your kit. So we talked about with a double reverse that you may need 2 motors to power the lifting. And in that case, how many motors are left in your kit? Do you have enough to both have a double reverse 4-bar as your arm with 2 motors and also have a claw at the end that has a motor? Or do you need to use a different kind of end for the claw design, like a plow or a scoop, so that you have enough motors? Something else to think about as you go through. So again, just from one last overview from what we've talked about in this video. So your swing arm is the simplest one to build. You're using a bar, a tower, and then the motor connected to some sort of gear that can power your arm. A 4-bar is made up of 2 parallel bars, your tool plate on the end, and also the tower that comes up from your robot. And again, that can be powered in a very similar way to the swing arm, with gears connected to a motor to lift it up and down. With a swing arm, you have a large arc that comes off. Your objects will not remain level. With a 4-bar, your objects can remain level with that end manipulator. However, there is a slight arc to go through that. And then with a double reverse 4-bar, this is the most complicated build. However, there is no arc, and it can keep objects level the entire time as it goes through. So I hope you have learned all about robotic arms and have an idea of how you can build these yourself and add it onto your robot to complete whatever you are trying to do and whatever task you're trying to accomplish. I hope to see you soon. Thanks.